Today, the standard requirements for a 2026 web application have scaled past the capabilities of basic client-server models. A simple request-response architecture is no longer the endpoint of development. To build today, you must navigate a stack that integrates AI SDKs, vector databases, and automated containerization pipelines, a significant leap from the three-tier systems of just a few years ago. Consequently, the software engineer has taken on the role of a systems integrator. The focus has shifted from writing every line of logic to managing how these complex, distinct services communicate. In this environment, generative AI handles the raw syntax. It generates the boilerplate, while the human engineer manages the overarching architectural logic required to keep the system stable. Success in 2026 depends on mastering the data flow between these technologies rather than the rote memorization of individual coding syntax. Navigating this ecosystem requires a specific pacing mechanism for technical growth, the 70% rule of learning velocity. This graph illustrates the diminishing returns of total mastery. While the first 70% of a technology can be learned quickly, the final 30% takes months of hyper-specialization, creating a bottleneck that prevents you from learning the rest of the stack. That 70% threshold provides the necessary knowledge to safely integrate a tool before moving to the next node in the architecture. In this video, we will apply this rapid scaling to three critical domains: backend architecture, deep learning mathematics, and DevOps deployment. We will construct our application layer by layer, beginning with the baseline requirement for any AI-integrated system: data validation. We start at the UI layer. While tools like React and Next.js are the industry standard, they introduce a specific risk when combined with AI. Many developers rely on static typing systems to secure their application data, assuming that if the code compiles, the data is safe. This animation shows the reality. TypeScript provides security during development, but that protection dissolves entirely once compiled into JavaScript. This leaves the application exposed at runtime. If an LLM returns malformed data, there is no mechanism to stop it from corrupting the system logic. To fix this, we have to move security from the build phase to the runtime phase. Schema libraries like Zod act as an active gatekeeper. They inspect every piece of data coming from an AI model while the app is running, rejecting anything that doesn't match the required structure. In an AI-native application, static types are a helpful guide, but runtime validation is the actual security requirement for the backend. As we move into backend communication, standard REST API cycles become a bottleneck for AI-driven interfaces. Waiting for an LLM to generate a full paragraph before responding creates seconds of lag. To maintain a responsive UI, the data must be delivered as it is created. This is the difference between waiting for a single data block and using server-sent events. By streaming data token by token, we provide immediate feedback to the user. This shift also changes how we store data. Traditional SQL databases are optimized for text strings, but they struggle to retrieve the conceptual context an AI needs. This necessitates the vector database, a system designed to store and search the high-dimensional mathematical representations of your data. Navigating a vector database effectively requires a baseline understanding of linear algebra. Every piece of information in this system is stored as a matrix. We aren't querying words anymore. We are performing operations on multidimensional arrays. The core of this retrieval is the dot product. Calculating the relationship between a prompt and the database matrix produces a semantic similarity score. The highest scoring row contains the relevant context, which is extracted and fed directly into the generative AI stream. This mathematical retrieval provides a level of contextual depth that keyword matching cannot reach. It allows the system to understand the intent of a query, not just the characters. Backend development is no longer just about moving strings of text. It's about executing linear algebra in real time. Zooming out to the infrastructure, a secure architecture is ineffective if the deployment process is unreliable or prone to human error. Containerization allows us to isolate these complex AI environments. By packaging the code and the database dependencies together, we ensure the application runs consistently across different servers. To manage changes to these containers, professional teams follow a protocol known as the GitHub flow. This begins with branching. isolating a new feature so it can be developed and tested without affecting the live production environment. Once the feature is ready, the pull request acts as a formal gatekeeper, requiring a peer review before any code can be merged into the main system. We automate this enforcement through continuous integration and continuous deployment, or CI/CD. As shown here, the CI/CD pipeline intercepts the pull request to run automated tests. If the code fails a single unit or end-to-end test, the pipeline blocks the merge automatically. Only after passing these tests is the code containerized and pushed to the cloud, ensuring that only verified, stable updates reach the user. These automated CI/CD pipelines replace risky manual deployment processes with a robust, automated, and verifiable safety net for the system. We have now constructed a unified 2026 application architecture, from the input layer to the deployment pipeline. The strength of this system is its integration. The validation layer protects the matrix calculations, which in turn power the streaming backend. Within this framework, generative AI acts as a highly efficient assistant, generating the specific functions and boilerplate required at each node. The human developer's role has been refined into that of an architect. You are directing the AI based on a deep understanding of how these systems must interact to remain secure. Your value is no longer defined by your typing speed or syntax knowledge, but by your ability to design and maintain a resilient, integrated system. In this new paradigm, prompt engineering serves as your primary architectural tool. Effective prompting relies on providing the AI with the 70% level of context we've discussed, specifying the exact math operations, defining the validation schemas, and deployment constraints the system requires. The developer who masters both deep learning fundamentals and DevOps automation gains a specific edge in delivery speed and system reliability. This architect manages the entire system from the top down, while the developer restricted to manual syntax struggles to keep pace with these automated scales. True mastery in 2026 is the ability to strategically guide artificial intelligence to build, test, and deploy systems that have become too complex for a human to manage alone.